right. Hi, everyone. How was lunch? Awesome. Wow, what a day, what a conference. I'm so excited to talk to you all about tooling like it's 2025. I am Josh, thank you for the intro. I work on a bunch of open source projects, mostly in the JavaScript, TypeScript ecosystem. I generally try to help people write code more quickly, with more confidence, with fewer bugs. I also wrote the Learning TypeScript book through O'Reilly. I'm told that we'll be having a book giveaway and signing at 5 p.m. in the lobby area near the bar, something like that. Very excited about that too. I'm also one of the two co-organizers and co-founders, or two lead organizers, of SquiggleConf, the conference, which takes heavy inspiration from JSHeroes. So before I actually start talking to you about me and tooling and all that, I want to give a big round of applause to the awesome organizers here. What a freaking conference. Oh my gosh. Seriously, consistently impressive. This is my second time speaking at JSHeroes, and I hope it is not the last. I work on linters. There are 3 common reactions I get when I tell people that most of my open source work is on the linter. The first is, cool. This is my favorite reaction. These reactions are sorted from least common to most common. The second reaction is more like this one, ew. That's okay, that's understandable. Not everyone likes the linter. A lot of linters in the past have been very rude, very opinionated, gotten in people's way. So I understand this reaction. But my favorite of the 3 is why? Why do you do that? Why do you, a developer with years of some sort of experience, choose to spend your time working on the little squigglies? And this might come across as the angry, weird grimace, but I think this is an awesome question, because then I get to pontificate. I get to tell people why I work on the linter. And I work on the linter because better linting, better dev tooling makes me a better developer. It's all about me, you see. Also, good tools let us use TypeScript better. Yes. I love this tradition so much. Thank you, Miriam. Great stuff. And it's also because AI is not a good coder. AIs are sloppy. They're incredibly powerfully good at making lots of code. They're incredibly bad at making good code. They write a lot of slop. And now there are 3 kind of common forms of static analysis that we can use to make ourselves better developers, to aid automated tooling. I'm not going to talk about formatters very much in this talk, although I do love them. They are great. Shout out Prettier and dprint. The 2 that I'm mostly going to focus on are linters and type checkers. So just to cover what we'll cover first, we're going to talk about type checking, yay TypeScript, linting, yay ESLint, pruning, which is, I think, a relatively newer area of investment for dev tools, and templates, because there's a lot of stuff, and it's sure nice to be able to reuse all of our config files. Dev tooling in general is a huge area, and there are major swaths of it I just do not have the time or personal expertise to cover. Building, bundling, unit tests, end-to-end test, integration tests, editors, most of AI. I'm not saying these aren't part of dev tools, I just don't have the time. So with all that being said, are we ready to dive in? Yes! Post-lunch, second day of our conference, we're ready. This is what we're going to cover. The 3 top layers: type checking, can I do this? Linting, should I do this? Pruning, is this even used? Do I need to do it at all? And then how the heck do I set that up? Templates. Let's start with type checking. What's everyone's favorite type checker? TypeScript. Woo! Now, if anyone wants a great talk to explain some of the awesome features and how to use TypeScript, Philip gave one yesterday. So I won't cover that stuff. Thank you for giving me a few minutes back in my slides. Yeah, Philip. All right, but once you understand and love how great TypeScript is, I have found there are kind of 3 common challenges with it that a lot of modern tooling can help address: adoption, power, speed. Let's go in order. Adoption. Within that, there are kind of 2 areas: converting your JavaScript to TypeScript, and then getting your TypeScript to build into JavaScript, amusingly. So for JavaScript to TypeScript, we had a great talk earlier from Sophie about converting your code bases. This entire presentation is just jokes and references to past talks. Now, it's fine to use any. Any is the, I don't know, I don't care, just let me do whatever I want type. And it's okay to use any because TypeScript is a gradually typed language. There's a spectrum of how what we call weakly typed your code is towards strongly typed. I normally use these emojis to describe it because it's funny, but weakly typed TypeScript is still good. JavaScript itself is effectively using any all over the place. So even if your code base doesn't use the most powerful TypeScript options and strict modes and all this, you're still TypeScript. You should still feel morally superior. Just kidding. Let's take a look at JavaScript. The big problem with JavaScript is that there's no built-in way to describe the intent behind your values. There are comments, but those are kind of soft, sort of spoken language text. There's no language way. This is fine in JavaScript land, but in TypeScript, well, this is actually also fine in TypeScript land because you don't need to type everything. If you're just converting from JavaScript to TypeScript, you can get away with implicit any's. There is a TypeScript compiler option that says, give me a type error if something is implicitly any, as in you didn't tell me what type it is and I can't infer it. So I'll give you this error, parameter food implicitly any type. Awesome. Who here likes Papanashi? Yeah. That's good, yes. All right. Now, there's also another interesting avenue, which is that you don't have to convert all your all your files to TypeScript at once. You can have TypeScript files importing from JavaScript, which means that this stuff is actually going to be implicitly any because TypeScript by default doesn't recognize JavaScript files. But there's a compiler option for that, which is that you can enable, pardon me, forgetting my slides. You can enable allow.js true. I'm just so excited to talk to you about JavaScript. You can enable allow.js true, which allows TypeScript to kind of read and guess what's in the JavaScript files. It will read the actual files. Here we see the hover that it knows data is Papanashi. So it is not quite as powerful as, say, giving type annotations, but it's pretty good. The next thing I want to cover is null safety. Who here knows what compile or what type error is going to happen on this slide? Show of hands. That's right, there's not going to be a type error because by default, TypeScript, like many older programming languages, will allow you to just pass null anywhere. That's not great. Null is not a string. This is not fine, dog, but I do want to, before I continue, say this fine dog is actually in a whole comic, the Gun Show comic, and they said goodbye to the dog character. Highly recommend reading. It's a great series. Anyway, no, this is the error you get if you enable strict mode or strict null checks true, which says no, you can't pass null in some place that's just supposed to be, say, a string. Awesome. So in general, I'm not going to dive into all the different options that strict true enables. Strict true is an umbrella. It enables a lot of great things. But I definitely recommend researching if you have the time. But OK, moving on. TypeScript to JavaScript. Because you have your TypeScript source files, but they need to become JavaScript to run. You can't just run TypeScript. One does not simply. Now, back in the day, what we would typically do is have something in our tool chain, maybe a Babel or Webpack or Vite plugin or whatnot, take our TypeScript files and then convert them to JavaScript. TypeScript comes with TSC, the command line, which can do that for you. Then you can run them in Node. What a schlep, what a process. So people made tools like TS Node, which is still pretty good to compile and then run your files for you behind the scenes. Node actually has support for loaders, which are things that intercept files and can, for example, transpile them. So you can kind of go through Node more natively. Still kind of a pain to write all this stuff, though. Fun fact, there is a proposal. It does not support dark mode yet, but it's open source, so if anyone wants to add types as comments to the language, but that's years and years away from landing, if it ever does. I also want to shout out other runtimes like Bun and Dino. Bun and Dino both have a lot of fantastic features. They have newer security models that are more secure by default. They have these performance things, API redesigns. A lot of work went into them, but the vast majority of developers I've talked to who use them just use them because they natively transpile TypeScript for you. I don't know how to feel about that. Wouldn't it be nice if Node did this for us? Well, as of the last major version or two, Node can natively run TypeScript. Yes! Yes! Streets ahead. Thank you, Node. Oh, so good. What a relief. Okay, now this is called type stripping. Love that name. Love that name. The reason why we call it type stripping rather than types removal or deletion, I actually don't know the exact reason why we went with this phrase, but technically it's very interesting. They don't delete the characters, they replace them with spaces. They replace all the type-specific stuff, the not JavaScript, with spaces. And the reason why they do this is so that the source maps line up. You don't have to fiddle with your source maps. It's really, really cool stuff. So I've talked to you a lot about important, good, useful dev tooling. But before I move on to linting, I wouldn't be a complete TypeScript developer and advocate and whatnot if I didn't go with the AI craze we're currently in. TypeScript is actually really useful with AI, and I'll show a quick example. Let's say that you're like me, and you just want to learn when you're in someplace new, what are the best things to do? I did ask a few Romanians for these answers. These are not actually from ChatGPT. So you might ask some AI, some LLM prompt, give me 3 suggestions, give me them as an array. You want JSON. And well, then you might say, oh, well, actually, I want to know what type it is. So give me like a string literal of what type it is. And then you might want to know, oh, is it accessible? So regenerate the response with an accessibility Boolean. And this is kind of a pain. Wouldn't it be nice if we had a schema for our JSON? Thank you, Sandina, yesterday, but that was a great talk, really, really good. But there's another option we could use, which is these are kind of just TypeScript types. So if you pass a TypeScript interface or set of types to the LLM, that generally works. But AIs are not reliable. You'll notice there's a trend in my speaking. AIs are not reliable. Much of this tooling is to kind of make sure they're doing what they're supposed to. So there's this really cool project from the TypeScript folks and others at Microsoft called TypeChat that not just allows you to specify the types that your response is supposed to come in, it will also validate the AI response and reprompt the LLM if it detects any type errors. So let's say that no one shouted this out. I don't think any of you noticed this. I said venue, but the response was name. It was wrong. So it will check the response type and let you know if the AI oopsied on you. It'll then give the type error back into the AI and then recheck until the AI gives back a correct response. That's really cool. Yeah. Awesome. Okay, so adoption, you can use TypeScript. Let's talk about power. Do we think TypeScript is like a powerful type system? Yes, yes we do. It is obscenely powerful. My SquiggleConf co-organizer, Dimitri, got Doom running in the type system. And by Doom in the type system, I don't mean he added TypeScript annotations to JavaScript. I mean he got a template literal type of the first frame of Doom by creating an entire WebAssembly runtime with garbage collection and L1 caching in the type system. I forget if it was hours or days that it took to render, but it was a lot. TypeScript, we got the power. We're good. But the downside of all that power is speed, because TypeScript is really powerful. And it's written in TypeScript, so it executes as JavaScript. And it gets slow. So there have been several attempts to create a version of TypeScript in native speed to kind of speed it up a little. TypeRunner in 2022, abandoned now. STC, 2023, I want to say. Rust, also no longer in development. Esno is a really cool research project that is years away from true stability. It's not a major ecosystem thing, but it's not quite TypeScript. It's kind of a even more advanced type system in ways. Nothing is production ready. My hot take is TypeScript is such a big language with such a powerful, really, really great team that if you want a native speed TypeScript, it's going to have to come from the TypeScript team. Which is what they're working on this year. Yes, TypeScript's rewriting and go 10 times faster. Yes. Yes, there are two types of people who hear that One is they get all excited. The other is they go, well, why not in my language of choice? Very reasonable question. Go has a lot of structural similarity to the way TypeScript is set up as a JavaScript project. I'd highly recommend watching that video. Anders shows side by side the source code, and in many cases it's virtually identical or just very similar. Really cool. And because this is a 2025 talk, I'm happy to say that about 7 or 8 days ago, they announced native previews of this new 10 times faster TypeScript. So if your TypeScript is slow, you got thousands, tens of thousands, hundreds of thousands of files. Try it out. It might save you some time. But OK, is TypeScript fast? Eventually, it will be. It is also pretty fast for a JavaScript project, I will say. They've put a lot of good effort into it. But moving on. Type checking was, can I write this? Is this the type-safe code? Linting is, should I write it this way? I know it works, but is this the best way or one of the best ways? Now, to recap what linting is, it's a set of rules that each individually enforce something. The core ESLint rule, logical assignment operators, takes a look at code like this, doesn't know if it's correct or not or type safe, but it will let you know, hey, there's a stylistic improvement you can make. Fun fact, there's this new operator, or equals, in JavaScript, and you know, I can suggest a fix to you. Code works the same, it's just a little cleaner and easier to read. If you don't like it, no worries, you can turn the lint rule off. But I think this looks pretty good, so I'm gonna keep that rule on. A few pro tips for ESLint. One is that whatever editor you're using, or NeoVim shenanigan, there is generally an extension for it. I also personally configure my editors to fix on save. I use a lot of ESLint plugins, so it's nice to have sorting of imports and such happen for me. I also get annoyed because ESLint and TypeScript both give red squigglies by default in most editors, which is confusing. It's hard to tell what's what. So I'm very happy about this. I added this to VS Code. A lot of extensions give a downgrade or change security or, change severity option. So you can downgrade ESLint to be yellow squigglies, even though it still fails your build. Much easier to read. Cool. But what we just looked at is a syntactic, a stylistic rule. It just looks at your equal signs. That's not quite the most powerful thing ever. It's not types. We're talking about the latest and greatest. And for me, the latest and greatest is that we've kind of made this new version or this new classification of static analysis. This combination of linting and type checking called type-aware or type-checked linters. Because linters can read in the type information from TypeScript and use that to make more powerful deductions in their lint rules. Let's take a look at an example. Does anyone know what happens if you await console.log? That's right, nothing happens. You waste a process tick. It's an unexpected await of a non-promise or non-thenable, something with a .then. It's a waste of code. It doesn't do anything. So you can just, as the rule would suggest, get rid of that little await there. Very nice. Who here's written await console.log? No one. So let's look at an actual real-world code example. One of the great benefits of linters is that they will analyze your code for you, even if the code isn't a language or type of framework you don't write. So back-end developers, this is especially for you because I'm showing React code. I'll just fast forward. There is an await onClick. OnClick is a function that returns void, nothing. Don't use this result. So the rule is write to complain. We shouldn't be awaiting that. One option could be to change the function to return a promise in types. But if we know the function is never asynchronous, we could get rid of the awaits. And if we get rid of the await, we then notice that per React conventions and how it works, we don't need set running true and then false, so we could get rid of that, which means that this async function, well, also, fun fact, another lint rule would let us know that you don't need to mark the function as async if there's no await, which means this function is essentially useless, which means, well, now the set running variable is unused. So the running state, well, that's unnecessary too, because it's always false. And button disabled equals false. Well, first of all, that's basically the default for the button. Second of all, is that even the right way to make accessible buttons? And oh my God, we just got rid of a third of our code with linting! Yes! Yay! Hooray! Awesome. Yes. I've been giving those slides for 2 years. That's my favorite. Okay, so now you're all pumped about linting, and like everyone in the industry, you're like, yes, I want to lint more, not less. Yes. Cool. So here are a few assorted lint rules that I find to be very fun and useful. For starters, there is a deprecation plugin that lets you know if you're using code that was deprecated. Fun fact, that plugin is deprecated. We added the rules to TypeScript ESLint itself because that's just so useful. There's a plugin around ESLint comments that lets you know, oh, hey, you disabled the rule, but you never explained why. It's generally better to explain why. Pro tip. There's a plugin for JSDoc. This is one of my favorite lint rules. It will yell at you. There are a bunch of rules, but my favorite is if you just write a comment that says the name of the thing you're commenting, because it's such a waste of space. Param ID, the ID. Why? JSX accessibility, or A11Y, letting you know for front-end-ish code if you, say, made an image without alt text. Man, accessibility is really important. Shout out to how to. Yes. Okay, ESLint plugin N, short for node, in case you, say, import from something that's not actually installed as a dependency or is installed as a dev instead of prod. This one I'm not so confident you will all like. Perfectionist allows you to sort everything alphabetically or by line length. I love alphabetical sorting of everything. It means I can search through lists in O of log n time. Thank you. I know it's not for everyone. One of the great things about linting is you can always turn rules off or not use them. But for everyone, and I mean every single node project, I really want you to use ESLint plugin regex or regex or regular expressions. It can detect improper stuff in your regular expressions, such as exponential, I forget what the term is, but the regular expressions that can accidentally cause a redos because they get so slow. Security is really important, by the way. And if you want a good talk about security, Attila gave one early in the conference. Okay. Highly recommend. This actually, I'm being silly, but this is actually really important stuff. There is a lot of great stuff you can do with linting. Okay. ESLint, because typed linting waits on TypeScript, is also sometimes slow. TypeScript's getting rewritten in Go. What if we rewrote everything in native speed code? There were 3 really popular re-implementations or recreations of a linter in native speed languages. I believe all 3 are Rust. Biome is awesome. DinoLint is awesome. OXC is awesome. That's pretty cool stuff. It becomes harder to integrate with typed linting when you're in Rust because typed linting is available. The type info is available in Go or TypeScript, traditionally TypeScript. There's also a really interesting project from Johnson Code HK called ESLint, which is TypeScript, but it integrates much more closely with the TypeScript language server. I'm also myself working on a new linter called Flint, the fast, friendly linter. It's not going to be ready anytime soon, but you know, it's an experiment. I don't know if it'll ever be ready. There are a lot of different approaches to fixing the performance issues with linting, and I got to be honest with you. Only my way is correct. Everyone else is wrong. That's a joke. Please don't subtweet me. But that's linting. I'm really excited about it. I hope to give you a talk in a year or 3 about how we fixed all the issues, and it's great. But I'd like to talk about pruning now, with the last of the 3 top areas, because this is cool stuff. There's a really awesome tool called Knip, Dutch for snip. Knip it before you ship it, used to be their tagline. I can't find it on their website anymore. But it will take a look at this file, or all your files, and it'll let you know if there's anything that's unused cross-file. Linters just work at 1 file at a time scale. This can work on your whole project. Who here sees the unused piece of code, the unused variable? Just shout it out. Banana! Yes, thank you. If you were to run Knip on this, you'd see, aha, fruits.ts exports banana, but it's never used by anyone. Knip might also let you know, not only do you have the banana wrong, you also might have an unused dependency in your package JSON. That's another thing I had never considered would be something we could scan for. Sweet. Now, just because you remove stuff from your package JSON doesn't mean you're done pruning, because the lock file in most modern package managers can still have unnecessary redundancies. Does anyone see the redundancy in this lock file? You have 3 things to look at. It's It's not a trick question. All right, well, example B, well, we have two resolved versions. I suppose I should have explained that format first. It's possible that if you add and remove a lot of packages, you might have two different versions of a package, even though they could be deduplicated. And most package managers have a command like dedupe, which will rescan your locked file and fix these little inconsistencies, reducing the size of your node modules. Sweet, that's good stuff. So that's pruning. That's not only did I write the code in the correct way, I want to make sure that it's not doing anything it doesn't need to. And I've shown you a lot of tooling, and you might be asking how. How do I set this up? And in fact, this is a subset of my common package JSON, and I've only covered about less than half of it. There's a lot of stuff to cover, and most of us are thinking, that's too much, man. I can't keep track of all this in my head. That's not empathy with the audience. I'm telling you, I can't keep track of all this. I need templates. I need some copy and paste that I can take between projects, because otherwise I'm not going to remember ESLint plugin N and Perfectionist and Knip and all this stuff. And back in the day in React land, does anyone remember Create React app? That was a great app. It set up a Webpack for you, saving you decades of your life. It's now deprecated, but npm create Vite, or Create Vite app, is a nice little replacement. Also, every framework has a creator template now. These are good starts. I'm happy about this. When I create a new Next.js app, I oftentimes just use Create Next app. But these are specific to the frameworks. And I've tried this out a bunch of times, and I've discovered that a good template, one that does more than just one framework, but all these comprehensive pieces of tooling, is actually really difficult to write. This is a hard problem in software engineering that we have not put a lot of effort into solving. And let me explain why this is such a hard problem. Suppose you want a template that just has these three concerns: formatting, linting, and type checking, the tools for them. Well, for starters, you might want to create two versions, one with JavaScript and one with JavaScript and TypeScript. So you might have like a -- TypeScript option. But then also, whether you include TypeScript changes the linter configuration. You might use TypeScript ESLint or not. And then as soon as you add in a fourth thing, say testing, well, the tester might need to know what your file extensions are, which changes, and then it also might have a linter plugin, ESLint plugin vtest for me. And then what if you have plugins for all those things, each of which might change some other part of the thing? And then those actually have a lot of outputs. There's the package JSON dependencies. It's not one-to-one with the config files. You also might want to set up CI actions, like a GitHub workflow. You might want to send a REST call to GitHub to change your repo settings. And then also, what if after you create your template and then create your instantiation of it, you then want to update if you want to transition from an old version of the template to the new version? And then also, what if you have variants you want, like the web extension version, or the CLI version, or the React version? I know I'm appearing positive, but this is really hard and annoying, and it kills me having to maintain all this stuff. So my hypothesis, last 3 to 5 minutes, my hypothesis is that we need a kind of component architecture the way a lot of front-end UI libraries do things, what I'm calling a blocks system, where each of your individual piece of your template can be declared independently as a block. This is, I think, maybe not the, but a right way to solve this problem. And when you separate out your template pieces into blocks, the way I've done in mine, you'll find that there are all these surprising pointy arrows of these dependencies between them that you didn't realize when writing, that like TypeScript depends on this. You need a framework. You need a system to do this. Much like how we graduated to things like React and Solid, I made a framework for this called Bingo. It is very new. It's stable, but not super stable. It's not 1.0 yet. And I used it to create npx create TypeScript app, or the V2 of this, which is how I now create all my repos. Here's a screenshot from VS Code of all the stuff that comes by default. And CTA, as I like to call it, makes me happy because I implemented the block system, and you can now configure between different presets. You can add and remove blocks as you please. If you want to get rid of some of the more Josh opinion stuff, you can just go with the minimal approach. And if you want the everything, which is what I use most of the time, you can go with preset everything, which adds in a bunch of blocks. And then you can also say add NCC, which is a nice builder, and remove tsub, the default builder. Now I know that folks in the back might not be able to see, so let's just move that up a little. But not only do they change the files, they also change the inputs to other blocks. The package.json block receives info on what scripts to add and dev dependencies to install. So I think this is a really cool approach. I'm really excited to see CTA and Bingo and hopefully other projects try to explore this template space. But in general, no matter what you do, my recommendation is learn all the tooling stuff you have the bandwidth for, and then automate it. Make sure that you don't have to keep learning and retyping the same stuff. Have a template. Okay, last minute, a few closing thoughts before I leave you. For starters, you can find my slides on joshuagoldberg.com/speaking. That's right, Tejas, they're PowerPoint. Take that, haha. Static analysis is awesome. Definitely try out typed linting if you haven't yet. A few favorite highlights, all of the tools that I showed have web pages. I also bought create-typescript-app.dev this morning, forgetting that Namecheap takes 48 to 72 hours to propagate, so that's just on my GitHub. And I know ecosystem advancement can be painful. That is just a slog to keep learning new tools. But we are advancing. We're making things better and getting new tools. So as painful as it can be, ecosystem advancement can be good. This is fun. This is useful. So don't let your tooling fall behind. Tooling like it's 2025. Thanks, everyone.